Welcome back to another video. In this tutorial, we are going to look at how we can understand the concept behind uh, angles that are between a line and a plane. Angles that are between a line and a plane. Between a line and a plane. Okay, so if you want to find the angle between a line and a plane, then one, you have to know that you're going to take the angle, okay, the angle between the line and the normal of the plane from uh, the angle 90, because if for instance this is a line and this, let's say this is a plane, right? So let's say you have the line here and this is a plane, okay, right? So this is what we have. This is the line, okay, and this is the plane, and you want to take the angle between these two, right? Then you have to take 90 minus the angle that is between the line and the normal of the plane. Okay, so the normal of the plane, right? So basically, if you are interested in taking the angle between a line and a plane, you have to take the angle between the line and the line and the normal of the plane from 90 degrees, and that will give you your angle between the line and the plane. Okay, so let's look at some important principles. Okay, so one, if the angle is greater than 90, okay, if the angle uh theta is greater than 90, note very well, if it is greater than 90, then your theta 1 will be equal to theta minus 90. That is how we obtain the angle between a line and a plane. So that is the first condition. So if the angle is greater than 90, then you are going to take 90. If the angle theta is um, if the angle theta is less than 90 degrees, then you're going to have theta 1 equals theta 1. Okay, so this is theta 1, so let's say this is theta 2. Okay, so that is going to be theta 2 equals 90 minus the angle that you obtain. So that is if the angle is less than 90. Okay, then you're going to take that particular angle that you obtain from 90. And if the angle is greater than 90, then you're going to have 90 from that particular angle. Okay, so these are the basic conditions that you have to note. Note them very well, because that is what is going to help us work our problems out. Okay, so let's look at, we are looking at this problem. Okay, so let's use this problem to clarify the concept of finding the angle between a line and a plane. Okay, so this is the problem. Okay, basically this is what we have, and we are told that A and B are points in space. Okay, so these points that are in space, they have been given by these position vectors. Okay, these position vectors, that is A equals 3i minus j plus 2k, and B equals I plus j plus k. Okay, so these are the position vectors in space. Okay, we are interested in finding the angle between the line AB and the plane. This is the plane. X minus 4y minus 3z equals 0. So now, what do we do? we have first, let's assume that the plane, which is the normal, okay, let's n equals x minus 4y minus 3z be the normal, of the plane, of the line and the plane, okay, of the line and the plane. Okay, so we have this. Now we have to note what we are going to use. We are finding the angle between the line AB and the plane. So basically, it's just like dot product or scalar product, but in this time, they have introduced a line. Okay, so here, the formula that we are going to use is going to be cos theta equals position vector AB times the normal, okay, over position vector AB, the magnitude of position vector AB times the magnitude of the normal. And that is what we are going to use over here. Let's dive into it. So here, our AB, right, is equal to B minus A, right? We know that to find the position vector AB, then it's going to be B minus A, right? It's either you use OB, right, minus OE, they are all the same, okay? So that is what we have. We know our A, we know our B. So position vector AB will be equal to I plus J plus K minus position vector A, which is 3I minus J plus 2K, right? So we have position vector AB to be equal to, we subtract them component-wise. So we're going to have I minus 3J, I minus 3I becomes minus 2I. And then J minus J becomes plus 2J. Okay. K minus 2K becomes minus K. Right. So we have the position vector AB. So looking at the formula, we need the magnitude of position vector AB. So the magnitude of position vector AB will be equal to minus 2 squared plus 2 squared plus negative 1 squared, right? So that is equal to negative 2 squared is 4 plus 2 squared 4 plus 1 squared 1, right? So that is going to give us 4 plus 4, that is 8, plus 1, that is 9. So that is basically 3. So we have our position vector, the magnitude of the position vector AB to be 3. Now we need the magnitude of the position vector N. Okay, so that is the normal. Okay, so we know that our N is equal to x minus 4y minus 3z, right, over here. So we need the position vector of this. So, okay, that is the position vector, right? So we need the magnitude. So the magnitude of N will be equal to square root of 1 squared plus negative 4 squared plus negative 3 squared, right? And that is equal to 1 plus 16 plus 9, right? So we're going to have 10 plus 16, and that is 26 in here. So we have the magnitude of N to be square root of 26. Wow, that is interesting. So now we have the position vector AB, we have the magnitude of position vector AB, and we have the magnitude of um, the normal, the position vector N. So the next thing we have to do is do substitution, and then we can find our theta. So right here, what we need from here is position vector AB times the n, right? So over here, we know that position vector AB is right here. Good. And we know our n, which is the normal to the plane, is x minus 4y minus 3z. That is supposed to be xi, right? So let's write it in the position vector form. So the position vector of n becomes I minus 4j minus 3k, right? So our position vector AB times n, where our n is here, okay, will be equal to AB is right here, minus 2I plus 2j minus k times I minus 4j minus 3k, right? So here, z minus 2I times I becomes minus 2, right? Then 2j times minus 4j becomes minus 8. Then minus k times minus 3k becomes plus 3 over here. So we have position vector AB times n to be equal to minus 2 minus 8 becomes minus 8. So minus 2 minus 8 becomes minus 10. So minus 10 plus 3 will be equal to minus 10 plus 3 becomes minus 7. Wow. So we have the value for the dot product of a position vector AB and n, right? So now what we need next is our theta. So we know that our theta, cos theta, is equal to position vector AB times n over position vector AB, that's the magnitude of that, right? Times the magnitude of the position vector n. Okay, so now we have every information that we need to substitute. So our AB, position vector AB times n is minus 7. So we have minus 7 over the magnitude of position vector AB is 3 times position vector n. The magnitude of position vector n is square root of 26. Right. So over here, we're going to have cos theta equals minus 7 over 3 times square root of 26. Right. So we're going to say that our theta is equal to cos inverse of negative 7 over 3 square root of 26. Right. So our theta will be equal to, when you find the cos inverse of negative 7 over square root of 26 times 3, you're going to have 117.6 2306, right? So we have our theta to be 117.2306 degrees. Now, this is not our end of our work, okay? Because we know that if you want to know the angle between a line and a plane, then you have to follow the conditions. One, if the angle that you obtain is greater than 90, then it means that you have to go and subtract 90 from this to have your actual angle or theta. Okay, so this theta is 117.2306 degrees. So for us to know the actual angle, then we have to say that theta 1 will be equal to 360 minus 117.2306 degrees, right? So our theta 1 will be equal to 360 minus 117.2306 is basically 242.7479 or 7974, right? Degrees, right? Then, since this theta 1 is greater than 90, don't forget we said if theta is greater than 90, if theta 1 is greater than 90, then you are going to take 90 from this angle, okay? So our theta, okay, our theta 1 will be equal to 242.7974 minus 90 degrees, right? So we're going to have 152.7674, right? Don't forget that this initial angle is 117.2306. So this is greater than 90. So we take 90 from this as well. So to have the other angle, right? So theta 2 will be equal to 117.2306 minus 90 degrees, right? So our theta 2 will be equal to 117.2306 minus 90 is basically 27.2 degrees. So from here, we can see clearly that our angles are 152.7674 degrees and 27.2 degrees. So these are the angles that are between the line and the plane. These are the angles between the line and the plane. So the angle between the line and the plane, the angles between the line and the plane are 27.2 degrees and 152.7674 degrees. That is what we are interested in. So basically, if you want to get your first angle, then you have to check, is the angle that I obtain after calculating everything, is the theta greater than 90 or less than 90? If theta is greater than 90, don't forget that this sign over here also counts, right? So if, for instance, you ignore this negative sign, then you are not going to subtract from 360, right? If you forget about this negative sign, then you are going to add this angle, that whatever you have, you're going to add it to 180 instead. But since you used all the values, you didn't avoid the negative, then you're going to subtract from 360 to get your actual angle. Then use that angle. If after subtracting you realize that that angle is still greater than 90, then don't forget the rule says that, or the condition is, if the angle is greater than 90, then it should be that angle minus 90. Then you have your theta 1. Then your theta 2 will be what you had minus 90, because absolutely this is greater than 90, then this one will be greater than 90. So that is when you have your other angle as well. That is the process. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'm going to give you more updates. Bye bye.